Well, thank you, everybody, and good morning. Hopefully everyone's enjoying the day. Smiles, smiles? No smiles? Yes, smiles. Okay, good. So just to start off with a question, what does infrastructure mean to you? Anybody? When you hear the word infrastructure, what does it mean? Okay, servers and networks, yep. Anybody else? Storage, yep, absolutely. Oh, now you're talking. Capacity and failover. Here's a few things that infrastructure means to me. From a cloud perspective, I'm going to be using a lot of Amazon references. So infrastructure can be static network. When I say static network, I mean typically things that don't change when you talk about your network. So in Amazon terms, this could be your actual VPC, your route table, subnets, that sort of thing. Dynamic network is also an infrastructure concept. So dynamic network are things that might actually change as your application gets deployed through its life cycle. So for example, a security group or a firewall. Then network appliances themselves are considered infrastructure mechanisms. For example, you may be using a proxy in your environment or a web application firewall, that sort of thing. Certainly you mentioned services like capacity, monitoring, logging. These are all support services that kind of fall under the infrastructure realm. And then somebody mentioned servers, right? So that's what the application lives on, the supporting stack. So in Amazon terms, EC2 servers, right? Or maybe you're using containers and using ECS service. Maybe you're using a whole variety of services to support your stack, including S3 for storage or ELB for load balancers or what have you. My point here is infrastructure can be a lot of different things. And one of the biggest advantages of the cloud is that you now have an API to interact with your infrastructure. So let's pause for a second, and if you can all humor me, can everybody just take a second to look up at the ceiling? How many of you walked into this room today, looked up at that ceiling and thought, wow, I really hope that ceiling doesn't fall down on me? Probably nobody, right? And that's because we have a really high degree of confidence in our infrastructure, this building. I trust whoever built this building is not going to fall down on me. But do we have that same trust and confidence in our cloud infrastructure? I won't answer that question. But I will say that in order to get there, to get some trust and confidence, we have to be able to meet some goals. So our cloud infrastructure needs to be scalable, right? It needs to be resilient, it needs to be secure. And what do I mean by that? So if you're going to scale, your infrastructure itself needs to deploy across any number of networks or accounts. And this is kind of a softer message, but the whole point of cloud to me is being able to promote innovation. And that comes from being able to make your developers productive. If your developers can't do their job in a cloud environment, then in my perspective, that cloud environment has not done its job. Your developers need to be productive. So when you think about scaling infrastructure, scaling these servers and things like that, a tangible example of this is servers in the cloud, their IP addresses change, right? Well, if your developers aren't used to that, then that may be a problem. Resiliency, right? So unlike this building, failures do happen in the cloud. Availability zones go down. Maybe a whole region goes down. Maybe you hit API rate limits in an Amazon account because you're, have just that much stuff going on. And from a customer perspective, whether that customer is your developer or the customer is an actual end user of the account, what they like to see if there is a failure, they don't want to see a 404 error or something like that. They want to see either graceful degradation or self-healing infrastructure. And then it needs to be secure, right? There is a notion of cloud makes it easy to enter, which is a wonderful thing. It's a very low barrier to entry. But if you work in an environment where you need to be secure, where I would hypothesize, and most of us probably do, the infrastructure itself needs to incorporate safeguards. And then how you actually develop and deploy your infrastructure, that needs to be done in a secure way too. So, it's easy, right? Okay, bad joke. It's not easy. And in my experience, I've come across a certain set of challenges that I want to talk about today. But I'm curious, those of you in the room that are working in cloud infrastructures today, what challenges do you face in meeting these goals? What stands in your way to be scalable, resilient, and secure? Anybody? US East 1? Okay. Anybody else? You must be facing some problems, otherwise you wouldn't be here today. Yeah.
The mentality that it's okay if that's down for a few hours until it goes down.
The mentality that it's okay if it goes down for a few hours? Okay. Yeah, for some apps, maybe that's acceptable, but for some, probably not. Go ahead.
Dealing with multiple cloud suppliers,
Dealing with multiple cloud.
providers, so unified API for Google versus.
Yeah, dealing with multiple cloud providers. That is a complex challenge. You can't treat them the same way.
Whether it's the app you're actually deploying can scale.
Yes, is your app actually aware of cloud enough to be able to scale? That one I'm actually not going to answer today, so sorry about that. These are some of the challenges I've faced in being able to make my cloud infrastructure scalable, resilient, and secure. So just to take them one by one, to give you an experience from my life story here, my first foray into Amazon, I was working on a pilot project, and I very happily used the Amazon console to create my very first VPC. I was so proud of myself. I was like, wow, I did it. I created a VPC. And next project, they were like, yeah, that's great, but we have 50 VPCs, so what? I was like, oh, well, now I need to figure out how to automate it. So I did. I wrote some scripts. I used both cloud-native technology, CloudFormation, and then I also used a tool called Terraform. And I was like, this is great. I've automated my VPC build. And then I got told, well, yeah, but you're still deploying it manually, one at a time. So your infrastructure is automated, but you're still going through the console for your CloudFormation tag or going through account by account using your access keys to deploy these VPCs. And that made me realize, you know what, orchestration is kind of important. And we'll talk more about that in a little bit. Reconciling human changes with automated changes. So this was a challenge that I faced in, I could automate certain things, and I could deploy that automation. That was all well and good. But then, good old human beings, we muck around in our environments, and something's changed, and I didn't know it changed, and my automation fails. Or even worse, something's changed, and again, I didn't know it changed, and my automation conflicts with it. So how do you reconcile that? How do you reconcile changes that were made manually with automated changes? Another way this problem presents itself is if you don't start with automation in the beginning. Then naturally, you start off with a human making changes first. So for example, creating a VPC through a console. And then later, you want to automate that process. But you don't want to manage your infrastructure two different ways. You don't want to manage the human stuff with the automated stuff. You want to manage it all in one way. And then finally, lack of understanding. So this is kind of an umbrella. Cloud is an education for most of us. But there is a fundamental lack of understanding that I faced when talking about infrastructure like VPCs and servers and things like that, of upfront having that discussion about, so we're creating it in one account today, but tomorrow it might be in 50 accounts. How are we going to handle that? How do you understand how to handle that? Resiliency. So you mentioned legacy apps and things like that. That's actually a good barrier for resiliency. One of the things I face too is just dealing with persistent data. So an example of this is MongoDB. It's a great database. I have no issues with the database. But when it's running on an EC2 server, it's kind of hard to scale that server that's running MongoDB because it's got persistent data on it now. No backup recovery plans. So what I mean by this is, from an infrastructure perspective, if you take that VPC example again, if your availability zone goes down, or worse yet, if your entire region goes down and you need your application to work in a different region, you have a failover strategy and it's a multi-region strategy. Well, how do you actually back up that VPC and recover it? You probably don't. Ideally, you already have a mirrored VPC in place. But things like that is to start to think about, how do you actually back up and recover your actual infrastructure? And then S3 is another good example. There are ways to replicate data and things like that on S3, but you have to think through, what is your backup and recovery plan for that service? And then remember that earlier slide where I said infrastructure can be many, many things. There really should be a backup and recovery plan for each of those things if that's what supports your application. Then lack of change, configuration, release management with adverse impact. So cloud makes things easy. I had a lot of access to things, which maybe I shouldn't have had. I made my own mistakes. I once, true story, was trying to add a security group rule. Very simple change. And the change was because an application had added an additional endpoint, so I need to talk to this particular endpoint. So I go through and I try to add the rule, but I've hit my limits on the number of rules in that security group. So I do what seems logical to me, which is, well, this endpoint and the second endpoint in this rule are pretty close together. I'll just combine them in a range, and that way it'll be one rule, have both endpoints, we're good. So I did that, thought nothing of it. And then I get a call from my manager and says, hey, you did your math wrong. I'm like, uh-oh, that's not good. Because did I mention this was a production change? Whoops. And an application actually started having issues because it could no longer communicate to the endpoint that I had inadvertently missed in my very bad math. So that was an example of not having followed a good process and not understanding the impact of that change, because if I truly understood that there were multiple applications using the security group and that all these endpoints were there for a reason, maybe I would have been a little bit more careful. So then secure, Wild West, attackers in the cloud too. What I mean by that is there's a lot of literature written about defensive security, things you can do to make your infrastructure secure, things you can do to make your app secure. But one thing that kind of struck me is the fact that our attackers are all in the cloud too. So they know what we do to defend ourselves in the cloud because they're already in the cloud too. And we'll more on that in a little bit. Insider threat, this hopefully isn't a case in your workplace, but it's something that highly regulated environments think about, is what happens if that privileged user does something malicious? Or a less way to say it, a less vindictive way to say it is, what happens if a human makes a mistake? Humans are fallible, we make mistakes. And then lack of automated controls framework. So earlier I said that one of the advantages of the cloud is that it's API driven. So the great thing about APIs is that it allows you to do automation, but that takes time, that takes effort, and in various places I've been, there hasn't been time and effort put forward to automate compliance monitoring and compliance remediation. And we'll talk about that too in a little bit. All right, so those are a lot of problems, and you offered some problems of your own. So this is my 2 cents on possible solutions to these problems. So you probably guessed it, automation, right? So for infrastructure as code, I think it's worth it to figure out what is your automation approach for infrastructure as code. And it may not be a uniform, one-size-fits-all type of approach, depending on what type of infrastructure you're talking about. So for example, your approach for your static network infrastructure, your VPCs, may be different than your approach for your dynamic network infrastructure, your security groups. And that's okay, as long as you have an automation approach. So the first bullet point, automate or not automate, to me, it's kind of a no-brainer. You automate if it needs to be repeated. It saves time, improves accuracy, reduces risk. You all probably know the benefits of automation. But when it comes to a business environment, it does take time and labor to automate something. And so there is going to be things, when you look at all of your infrastructure, there is going to be times where you're going to have to prioritize and trade off what do you automate in that and what do you not. So automate now or later. So again, that goes back into that whole prioritization, that trade-off conversation. And part of this is understanding, if you automate later, do you have a way to import manual changes? Because remember, you don't want to manage things in a different way. Is your target that you're automating actually stable, or is it always going to change? And then another key consideration for automating now or later is whether or not you have the requisite skill sets. So if your team doesn't know how to automate, but they have the time to learn and ramp up, then that's great. But that means you don't automate day one. That means you automate when they actually know how to automate. So centralized or decentralized, this is an interesting governance question, and it should be answered up front as part of your automation approach. So who controls the automation? How is that access federated? Take the case of a security group, right? A lot of philosophy around, does a security group belong to an infrastructure team, or does a security group belong to the application team? Anyone have an opinion? Oh, come on, you gotta have an opinion. Application, all right. Anyone feel strongly that it should be the infrastructure team? All right, see? Good.
I think it should be both, but.
You think it should be both? I've seen it play out in all three of those scenarios, and I'll give you a little background on those. So I've seen situations where there's a concept of shared security groups. So maybe there's a common proxy that services are using, common DNS, things like that. That shared security group I've seen being controlled by the infrastructure team. Generally speaking, they were the ones that had the most knowledge of those shared services, so it just kind of made sense. And then I've also seen situations where application developers could control their own security groups. And I've also seen situations where they could control their own security groups, but not in production. They could control it in development in order to test it, and test in order to test it, but then production was actually controlled by a release team. But the reason that's important to understand who controls your automation and how that access is federated is that it's going to directly influence your actual automation approach and your actual automation process. Finally, automate using what tool? There's a zillion tools out there. I like a bunch of them, though you obviously don't have to use my own personal biases. But my recommendation here is when you decide to use a certain tool, it's always a good idea to do a quick analysis. And when I analyze things, these have proved to be successful for me. The actual functional requirements, usability, cost, and maintainability. So what I mean by maintainability is just because I like a tool doesn't mean that my team knows how to use the tool. And so if I'm the only one that knows it, then it's not very maintainable. Cost, of course, there might be some hidden costs and total cost of ownership. It's worth understanding that. Usability, there's again, the dev side, you're going to develop using the tool, so it has to be usable. But there's also the ops side, is you need to be able to maintain the tool itself. And then functional requirements, so yes, this is requirements like, does the tool do what you think it's going to do? Does it provision infrastructure? Does it configure infrastructure, or what have you? But it's also worth thinking about functional requirements like, does it fit into your automation approach? Like if you have an orchestration process defined, does it actually work with that? If you're using multiple clouds, does it work with that? How will you build in quality control? That's an important consideration because just like developing applications, it's important to develop quality infrastructure. We want to have confidence in our infrastructure, right? So what does quality control mean? And we'll talk about that in a little bit. And then, of course, one of my favorite topics, how do you build in security? So these questions are just kind of meant to make you think about while you determine your automation approach. So the big thing here is it's not just the tool. The tool is what enables the process. But in order to come up with a good process, in my opinion, you need to have the right mindset. And so what do I mean by that? The DevOps mindset is what comes to mind. How many people here are DevOps practitioners? Awesome. So this will hopefully resonate with you. So when I think about DevOps, I think about collaboration, of course, and those good things. But I also think about the whole idea of CI/CD, continuous integration, continuous delivery, right? So everyone knows you have a pipeline to support your application code. What I'm talking about here, though, is that same concept of a pipeline, but apply it to your infrastructure code. So apply it to that networking code, apply it to that servers. Whatever your infrastructure is, apply it to that. And what that comes to is really thinking about how do you actually orchestrate all that? Like, what is your actual starting point for your infrastructure process, and what is your output? So if you take it at a very high level, that CI/CD pipeline can be broken down into a develop phase, a test phase, deploy phase, and monitor phase. Now for software code, typically you see develop, build, test, deploy, monitor. For infrastructure, you don't necessarily have a build phase so much, so I haven't shown that here. So at a high level, in develop, you're going to be looking at your source control. Test, you look at your testing pyramid. When I say testing pyramid, I'm referring to the typical pyramid where you have unit testing and then functional testing, integration testing, and UI testing. And then you have deploy, where you're actually deploying your changes. And then, of course, monitoring, we're going to monitor them. And so my point here is we want to use the same best practices that we've seen for developing software for developing your infrastructure. So the first overlay that comes into this is from configuration management. How do you integrate good configuration management into developing your infrastructure as code? So from a source control perspective, these are things like version control and tagging. And then metadata-driven changes. So what I mean by that is if you think about an infrastructure component like a VPC, the metadata for the VPC is going to be the variable parts of the VPC. So for example, your CIDR block, or maybe the purpose of that VPC. How many of you have a difference between your dev environment and your production environment in terms of your network? Yeah, lots of hands. That's a pretty standard thing, is you have a defined standard definition for what comprises a dev environment, and the same thing for what comprises a production environment. And there's usually slightly different rules. So a common rule that I've seen, for example, is no IGW or internet access in a dev environment, but there is an IGW in production because the apps are internet facing. And so metadata-driven changes means your actual VPC, that software construction of VPC is the same. It's the same API call in both cases to create that VPC, but the purpose is different. And maybe the purpose is denoted by a tag. And certainly CIDR blocks and things like that are different. So your CIDR blocks, your tags, things like that is your metadata. And my point here is you should also be controlling your metadata because it's the relationship between your metadata and the actual thing that you're building that gives you the whole view of your infrastructure. And then from a continuous monitoring perspective, it's really important to understand your configuration changes, right? So back in the day, people talked a lot about configuration baselines, and they had giant CMDBs, databases of configuration baselines that nobody, honestly, I don't think, ever actually looked at and had very little value. But from a cloud perspective, a lot of your inventory is going to be dynamic, but you still need to know what impacts what so that for troubleshooting and things like that, you can understand how to solve the problem. So on that note, I'm going to transition a little bit to this slide where I want to recommend something called GiveFlow. And many of you may already be familiar with GiveFlow. Who here already knows what GiveFlow is? Cool. So this is the same idea of GiveFlow, but just applied to infrastructure. So if this code was really related to a VPC, it's the same idea where maybe develop means you're testing it out, and then master is what's actually deployed into your cloud environments. Now, the metadata thing you see here on the bottom is the idea that you actually preserve your metadata in your repositories also, and then you have your infrastructure reference, which is the thing that you're actually building, also in your repositories. So if this was using CloudFormation, then your CloudFormation template might be the thing in the middle. Let's see, does this laser? There we go. That might hold your CloudFormation template, and then your metadata repository might be your actual parameters for that CloudFormation template. If this was a Terraform script, then this might be a Terraform module, and the metadata is your variables file, that sort of thing. And then it's totally up to you how you actually do your organization and classification. Maybe you do it by environment, maybe you do it by application. It's whatever makes sense to you. And then these are inputs into your orchestration engine, lots of them out there, Jenkins, Drone, whatever floats your boat. The point is, the orchestration engine, in terms of automation, should be able to understand if a change has been made, whether that change is to metadata, meaning there's an update to infrastructure, or a change to the actual reference itself, which means that that change should be applied everywhere. And then you do a test cycle, and then you do your final deploy cycle. Any questions on this so far? Okay, so now let's talk about the change management overlay. So we've got good configuration management. Now we want good change management also. So from a change management perspective, I've included unit and integration tests here. Many of you may already do lots and lots of automated testing for your applications. What I'm talking about is doing automated and potentially manual testing also for your infrastructure. And then from a scalable deploy perspective, I was once in an environment where I had to mandatory wait 7 days before I could deploy to production. And that was not very scalable because I had to wait 7 days. So what we talked about, and this was an education process, was how can we automate this? And they had a concept of something called standard change requests. Now, if any of you work for the government, I will tell you that standard change requests apply to the government as well, and they will allow you to use standard change requests in order to automate the change management process, which is kind of a cool thing. So to automate change requests, hopefully your change request tool has an API, so you can get a fully automated process. If not, if it's not having an API, then at the very least, from a process perspective, if you can get something called that standard change request, you can at least move much more quickly. From a testing perspective, many tools that support infrastructure provisioning also support unit testing. So for example, CloudFormation has a capability called change sets, where it will actually tell you, it will calculate for you what it thinks the change will be for the new stack. The tool Terraform gives you a command called plan, where you can review somewhat what it thinks it will actually change. And then the tool Ansible gives you something called assertions, where you can actually assert to see whether or not a change that you've applied is there. You can actually, of course, deploy it in a sandbox or lower environment. I highly recommend that if you have the time and ability to do that. And then end-to-end regression testing is really important. So if you go back to my security group example, where I completely messed up my subnet math, I did test my security group in that I knew my security group change was going to work based on my automation. But what I did not test from end to end was the actual application's use of that security group. So if you go back to that whole DevOps mindset, what I really should have done is worked with the application teams to let them know that I was making this change so that there could be an end-to-end test from the application's perspective to regression test that infrastructure change. Okay, the next overlay is from release management perspective. And here we talk a bit more about quality control. So remember earlier I said we should consider how do we bake in quality control into our infrastructure process. So one of the ways we do it is through best practices like Git flow. There's also something to be said for peer review. So in that Git flow model, if you refer to that, there's a whole idea of merging branches when it's time. And peer review is a great time for a human to actually put an eye to that code and look at it. And when peer review is done correctly, it can be very efficient. It can only be a couple minutes, and it can actually give you certain criteria that you're looking at. So for example, if you do that with an infrastructure person, with an infrastructure mindset, then what you're looking for is things like, hey, did you just open up a port that's going to open a vulnerability? Or, hey, you actually aren't aligned to our standard VPC guidance, or what have you. And then traceability agile, this is kind of a specific one. You may not be doing agile, but if you are, then from a quality perspective, you want to be able to trace your infrastructure code back to your agile requirements also. So if you're an operations team, a lot of times infrastructure falls to operations. This might be trace it to your Kanban board. And the reason for that is many of us have to report back to project managers at the end of the day and tell them what we've done. And so that traceability is useful. So for scalable deploy, I talked about orchestration, right? So we know there's orchestration engines, but from a process perspective, if you have to scale to support multiple accounts, multiple VPCs, things like that, you need to think about how are you going to orchestrate that change. So if you take an Amazon-specific example, you have your orchestration engine running in a common area, probably called shared services or something like that. But you need to deploy to multiple accounts, and you're deploying infrastructure to multiple accounts. Maybe you have a shared security group that you're deploying to multiple accounts. So you have to think through that. Like from an access perspective, how does that work? Sure, you can use access keys, or you could use the best practice of cross-account IAM roles. And what I mean by there is all the target accounts, you can actually set up a role that your Jenkins or whatever your orchestration engine is can assume to actually deploy your infrastructure. But it's things like that that you have to think about when you're orchestrating your infrastructure change. From a continuous monitoring perspective, I find it useful to be able to get data. Qualitative data is not really as data-driven as quantitative data. So from a continuous monitoring perspective, you want to get metrics around your actual infrastructure. So certainly these are metrics like performance and things like that. But when you're thinking about scaling your infrastructure as code, you may also want metrics around things like number of successful deployments and stuff like that. And then continuous monitoring in terms of agile stories, I'm a big fan of continuous improvement. And so for me, continuous monitoring to me also means when I'm monitoring my infrastructure as code and I have an idea for improving something, I'm going to feed that back into my agile story development, my backlog, my requirements, or what have you. And then finally, security overlay. Okay, so from a source control perspective, to me, security basically amounts to secrets management, right? We all know don't publish your AWS access keys on GitHub, but there's also something to be said for managing your actual secrets. Then from a testing pyramid perspective, this is the time you would inject your security testing. For deploying in a scalable manner, you want to think about things like encryption of data at rest and transit, logging for audit, and we'll talk a little bit more about that. And then from a continuous monitoring perspective, here I think is where the cloud is very powerful because of those APIs, is you now have the ability to actually do adaptive security based on the controls framework. Now what do I mean by that mouthful? So what I mean by that is you should be able to, working with the organizations, define your controls framework. So for example, take that VPC we're talking about, dev is different than prod, and maybe the rule is dev should never have an IGW. Well, guess what? That's now a control. Dev should never have an IGW. And you can actually automate that control. Using Amazon APIs, you can monitor whether or not a dev environment ever gets an IGW. And then you can define your remediation. What do you do if that happens? Do you notify someone? Do you just terminate the VPC? The answer will vary depending on your organization, but those are the types of things you can think about. So just some details and examples of the security side. So access we talked about a little bit on that from orchestration perspective about cross-account roles and things like that. But there's also access to be considered at every point of your actual CI/CD pipeline, and of course authorization there too. And then network boundaries, it's another thing to think about in terms of your frameworks. So do you have certain policies with respect to your security groups? Like, do you have a rule that says you should never have inbound all for SSH? Or if someone's working from home, you don't want to allow their IP range. I don't know, but if that's your rule, then that's something you define. Same thing with routing policies. Do you have a difference between private route tables and public route tables? And how do you preserve those differences? Security boundaries, this is often important for accreditation. But here what I'm talking about is it's really important to define the scope of your data or the scope of your application within the purpose of an account. So if you do have a sensitive application, PCI data or what have you, and it's sharing an account with non-sensitive applications, and you're making an infrastructure change in that account, you need to understand what was that scope of that PCI application versus everything else so that you don't inadvertently open up a hole. And RTO, RPO, so that comes to resiliency, right? And that we talk a lot about disaster recovery, failover, things like that. My point here is just it falls under the realm of security for me because it falls under the realm of resiliency. And then encryption, data in transit, data at rest. So everyone here, I'm sure, is already familiar with shared security responsibility model. Yes, it's possible to encrypt on most Amazon services, most cloud services, but it's up to you to make sure you're configuring your stuff to actually use it. And then there's also questions around encryption, around what keys to use, who manages the keys, and depending on your organization, they may be different answers. But all these clarifications that you receive, all these answers that you receive, they feed right back into that framework that I'm talking about, that controls framework. And then part of that framework is also defining what can be automated and what can't. So if you have a really specific requirement around thou shalt use this particular key, that's something you can automate and control. Logging is a big deal, right? A lot of different ways to log, a lot of different ways to mine logs. What I like to think about is you collect the logs, but that doesn't do you much good unless you can also analyze the logs. So there's lots of processes around there. And then the last point I think I want to raise is balance freedom and flexibility for the productivity of your users. So again, this goes back to my point about making your developers productive. So if you have a policy, which you very well may, that you should only use encrypted EBS volumes for your EC2 instances, that's all well and good. And you may have that automated so that you can also just not start instances if they're not encrypted. Again, all well and good. But if your poor developer is sitting there trying to launch their instance and it never launches, it's not going to be very obvious to them that it didn't launch because they didn't use an encrypted volume. So my point here is you kind of want to balance that type of aggressive remediation with the productivity of your developer. So ideally, if you're doing this in dev first, they get used to that, and maybe that's where you go into constructive compliance, where instead of terminating it, you send them a notification instead. But then maybe that's a really big deal in prod, and by that time, you can kind of expect that the developer will have learned and shouldn't be doing that in prod anyway. So here's an example of just looking at EC2. So earlier, someone in the room mentioned servers as part of infrastructure. So this is just a couple quick questions around how you could go through determining your framework for EC2. So criteria of does it operate within the VPC, does it encrypt data at rest, that sort of thing. And then guidance. This is not meant to be prescriptive, it's meant to just jog your thoughts around some of the guidance that you might be developing for your particular organizations and projects. And then the compensating controls is basically saying, if you're, like, how do you actually compensate for something that's not done out of the box? And then this is where you get into understanding what you can automate and maybe what you don't. And that kind of goes back to that automation approach from earlier. Okay, so security strategy can encompass a lot of different things. We talked about logging. In Amazon, there's a lot of different sources for logs. They should, in my opinion, all be considered. And remember, we talked about encryption, right? You want to make sure your logs are encrypted too. And then there's a whole discussion around Amazon machine images and static scanning. I could do an hour just on that probably, but I don't want to bore you today. My point here is from an infrastructure perspective, when you look at infrastructure as code and you're using Omni, it's really important to think about what is your Omni strategy? Like, are you baking Omnis? Are you not? Are you refreshing them? Do you have rules around refresh? And that goes back to your compliance requirements. How is your security even determining whether that Omni is good or not? Are they just doing a static scan with Fortify, or do they actually have some runtime compliance capabilities? Depending on the answer, you'll have different types of flexibility. And also, from a security testing perspective, if you're creating Omnis as part of your application pipeline, can you actually interact with your security tooling during that pipeline? And if you can't today, is that a requirement you can put on your security teams to make that available? Runtime compliance, I think, is a good goal. And then finally, network control points. So these are points that you can monitor, that you can include as part of your infrastructure as code policies. So if you know, for example, from a proxy perspective, that it's your regulation that your traffic should never egress through the internet, it should always go through a proxy, that's, again, something that you can codify. Okay, continuing on with security strategies, you think about infrastructure as code. Forensics is an interesting one. Depending on your organization, you may have different forensic strategies also. But the common requirement with forensics is that they have to have a way to detect, isolate, and analyze incidents. So for example, if something goes wrong on a server, they have to have a way for their forensics tools to get to that server, quarantine it, and do their analysis. So from an infrastructure perspective, that basically means quarantine the network, put a firewall around it, a security group, and only allow the security forensic tool to access it. Well, if this was an application in production, maybe your business owner doesn't want the end users to suddenly not be able to access their app anymore. So that means in terms of forensic process, you should also already have a process in place that allows your end users to still get their functionality. So maybe you mirror it, maybe you fail over to a different instance and just quarantine this one, whatever the case may be. But from a strategy perspective and automation approach perspective, it's a good idea to think about how are you going to support forensics. Continuous monitoring, I've talked a bit about automated compliance. Just a shout out to automated configuration management. I'm spending a lot of time today talking more about the provisioning of infrastructure, the actual launching of it, but there is a number of different ways to look at the actual configuration of infrastructure also. From an AWS perspective, they have a neat service called AWS Config, if you're not already familiar with it, which will give you a dynamic inventory. And then you can do config rules, which will give you a way to use Lambda functions to monitor and remediate. And the interesting thing here is if you choose to use any of these tools as part of your strategy, remember earlier we talked about scalable, resilient, secure. You want to make sure you're doing those three goals for this type of tooling as well. So just to pick on AWS config and config rules for an example, that is region specific. So if you're operating in a different region, you should have a way to automate the deployment of your config rules to the second region so you have the same type of compliance, that sort of thing. All right, so just a quick demonstration of what I'm talking about. This is a basic pipeline for infrastructure as code. My infrastructure here is happens to be using Terraform. So this is a Terraform module for creating a VPC with a number of VPC components. This is another repository, which is basically having the metadata for that particular VPC. So in this case, very lightweight. I'm having to use Jenkins here for orchestration, and this is a very simple pipeline. So I don't know actually how to pause this, but what this pipeline is doing is it's polling both of those repositories, and when it finds a change, it basically polls both the reference module and the metadata, and then it deploys the change. And here what I'm showing you is what the result of that change was. So in this case, it's finished running, and I've built my new VPC using Terraform, and it's got all the different components that I've specified. So it's got a number of public and private subnets, it's got a public and private route table with certain rules that I've configured in it, and it's got a VPC endpoint. Whatever the case may be, this would basically be representative of your infrastructure components. So now what I'm doing is I'm going to make a change to my metadata. So this is all well and good, but instead of calling it my VPC, I'm changing the name of this. So using good Git practices, I'm now committing my change into Git. In this case, I use code commit, mostly because I simply did not have access to GitHub. That's another story for another time. And then the same thing happens. Basically, the pipeline kicks off. It understood that there was a change, and it's going to deploy my change to that environment. Now, what I didn't show here, though, is the full Git flow model. And then just to show you the logs of what it does with the change, it understood that it doesn't need to create anything new in terms of infrastructure. It's just making that change to the VPC name. And like I was about to say, I didn't use the full Git flow model for this particular demonstration. But what I wanted to talk about there is it really depends on, in terms of your orchestration process, what your target is. So you may very well have different processes for dev environments versus staging versus production. So in this case, this was pretending to be dev. I had a plan here. I could have actually paused the pipeline at this point, sent this back to Git, issued a merge request, a pull request for review by a human being before it's merged, and continues the rest of the process. So again, it kind of depends on what is your overall automation approach, who controls your automation. If this was production, maybe that pull request is controlled by a different team versus the team that's originating the change, things like that. Okay. So we talked a lot about compliance. So this example does use AWS config. So I've created my VPC in that earlier example. But here, my config rule has noticed that it's actually not compliant. My config rule here is actually just checking for a particular tag. So tagging strategies are very important in terms of compliance operations. And in this case, it's saying this VPC was built without a tag that was required. So I'm going in and fixing the code here to add that particular tag. And my hope is once the tag is there, the whole pipeline will rerun, deploy the change, and it will be compliant again. So it's a very simple example, but hopefully it shows you an example of how that automated compliance framework can work. So I've defined the rule. I need a certain tag for my VPCs. I'm monitoring for that. AWS config rules is doing that for me. And I'm taking an action based on that. Now, this can be more elaborate. It could have sent me a notification instead of me actually looking at the compliance dashboard. The remediation itself could have also been automated versus me changing the code here. It could have just added the tag for me. Again, it just really depends on what policies do you define for your automated compliance framework. So again, I'm checking in my code to Git. So the pipeline has pulled, so it automatically found that there was a change, and it reruns and deploys that same VPC. And similarly to the last demo that you just saw, instead of recreating everything, it just changed it. And now here I can see that my change has been applied and it's now compliant. All right, so some takeaways that I hope you can all leave here today and start practicing if you're not already doing. If you don't already have an automation strategy for your infrastructure, go ahead and start defining one. Use a CI/CD pipeline. You probably already do for your applications, so start using one for your infrastructure too. My recommendation is do think about your orchestration first. We all know certain best practices for developing secure application code. Same thing applies for infrastructure code. Define that governance rule, that control framework, and implement automation for it. And then finally, implement with scale in mind. So if you are going to deploy something today for one account, think about how you're going to deploy that if it was 50 accounts or 100 accounts. All right, any questions? Nobody has a question? Come on, I'm not that good. All right, well, if there's no questions, I guess you're free to go to lunch. Thank you.